You want touch this, huh? I'm recording.
It is no misunderstanding, Princess. It is a confirmation of my prophecy. Left unchecked, Liu Kang will conquer Outlaw. I apologize for not arriving sooner to defend your sister. I'm glad she received her treatment.
The princess is safe, but the threat from Earthrealm remains.
Yes. Quan Chief, when do you anticipate a strike? Soon. Today's events were foretold in the final quatrains of the prophecy.
Kailangan mo ako.
Now, Princess.
I will take your concerns to the It is for her to decide.
Pictures, pictures. Wag, daddy. Pictures, 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 pictures. Yeah. Di.
What truly happened here, sorcerer?
That the Earthrealm has interrupted the princess's treatment was happenstance. They were here to capture me for Liu Kang.
You? Why?
That I must investigate. For now,
Why did you touch? I said don't touch.
Earthrealm of serendipitous arrival has given us ample evidence to convince the Empress of the truth of Quan Chi's.
Conflict with Earthrealm is now inevitable.
Not necessarily. The Empress has never been eager for conflict.
If she resists, she will be replaced. Outworld needs a steadfast leader.
A leader like you, perhaps.
If my realm requires...
Darius, don't go there.
Wag nga muna.
Saan po ganda yung ano?
Doon sa ano, yung Brooks kanina. Akala ko na
Ayun po.
Pre, may extra pa dyan, tiba? Pre, yan, ano yan? Pre, ano yan? Wala? Mas malaki yung, ano yung mas malaki, pre? Sige, na lang.
Pwede rin yung isa. Lipat
Lipat mo na.
Yan. Dali. Dali. Okay, dali. Ano? Sige, sige pa. Sarap! Dito ako sa buwan. Wala dyan, eh. Wala marami.
Do not go there, I said. Move here. You're not allowed to go there. They're working.
Laging chinelas siya. Kaya kung gusto mo ng chinelas?
Okay naman ako. Malamigin mo na. Malamigin mo yung pagkasama.
Yes? Rochelle, where'd you two meet? Airport.
At bar, the airport.
We're getting close.
What did you eat? Pesky nose against the glass.
I was one right glass. I didn't know it. So there's
Universe studies.
NASA's revolutionary Juno probe is on a daring voyage to Jupiter. Its goal? To reveal the deepest mysteries of our solar system.
Everything we see in the solar system today is affected by Jupiter somehow, in the past or now. All the asteroids, all the planets, moons, the comets, everything.
So in many ways, Juno is actually giving us a view into the history of our planetary system, even the history of Earth.
Juno's mission is risky,
Jupiter can eat the spacecraft like that.
but by diving perilously close to this monstrous world, Juno could change everything we know about our solar system.
If you want to know what's happening, you got to get up close and personal.
Our solar system plays host to some epic natural wonders. The ice geysers of Enceladus, the giant rings of Saturn,
Sakit ng tiyan na may pangangasim? Baka hyperacidity na. Hindi sapat ang pain reliever lang. Kreml Tablet ang tamang gamot.
the Martian megavolcano, Olympus Mons. But in July of 2017, NASA's Juno probe skims the surface of Jupiter and photographs the most famous natural wonder. A fierce hurricane-like storm that's been raging for hundreds of years.
When you think of Jupiter, one of the most visually stunning, most iconic features of the atmosphere is that great red spot.
There is nothing like Jupiter's red spot in our entire solar system.
As Juno soars over the Great Red Spot, it looks down onto a storm over 10,000 miles across.
This is the most extreme storm. The winds are blowing continuously at 400 miles.
On Earth, the most powerful Category 5 hurricanes can unleash almost total destruction. But these are less than half as powerful as the storm on Jupiter.
The Great Red Spot is the greatest hurricane that you've ever imagined.
But that's not all. Juno's microwave radiometer allows scientists to see through Jupiter's cloud layers for the first time.
Juno
Bravo.
has instrumentation that's able to look underneath. So one of the things we did was we looked at how deep are the roots.
Juno peers down into the eye of this monster storm. It spots temperature changes far below the surface that follow the storm's iconic shape, tracing the roots of the Great Red Spot deep into the Jovian atmosphere.
They found out that it goes down over 200 miles deep into the atmosphere. There's nothing like that on Earth.
Sabon, try. Safe na.
The Great Red Spot is a giant hurricane.
break, converting sound energy into heat.
Sound waves all crash together, creating a tremendous amount of energy and heating the gases around it.
Jupiter's Great Red Spot has helped heat the Jovian atmosphere for hundreds of years. But new images suggest that this may be about to change.
Jupiter's red spot is so big. It's bigger than Earth by a long shot. It seems like it would be an incredibly stable thing. It's just there, and it's always been there, and it always will be. Recently, we've seen it changing.
When NASA's Voyager space probe visited Jupiter in 1979, it observed a storm twice the diameter of Earth. In 2017, Juno's images showed the Great Red Spot has lost a third of its width. But that's not all. Despite the scale of
So the team plans to go out with a bang.
Risking permanent loss of communication. However, the team of scientists refused to give up. They made the bold decision to reallocate code to other areas of the probe's memory. This process began on April the 18th, 2024, and came with a great risk. The signal took 22.5 hours to reach Voyager, and it takes the same amount of time for a response. Every attempt was a step into the unknown. Just 2 days later, after months of intense work and anticipation, something incredible happened. Voyager 1 re-established contact. What extraordinary discoveries did the Voyagers make at the boundary of the solar system? Why did it turn out to be so different from what scientists had imagined? and what was contained in the mysterious signal that Voyager 1 sent after months of eerie silence.
Dahil ng mga parts.
In the late 1970s, a rare event occurred in the solar system, a planetary alignment that happens only once every 175 years. In that moment, the gas giants lined up on one side of the solar system, creating a unique opportunity to study them in a single mission. NASA seized this chance. Voyager 1, launched after its twin overtook Voyager 2 thanks to a faster trajectory, reaching speeds of 38,000 miles per hour compared to Voyager 2's 34,360 miles per hour. Just 13 days after launch, it captured an historic photo of Earth and the Moon from a distance of 7.2 million miles, which became the symbol at the start of their grand journey. In 1979, both probes reached Jupiter, revealing its previously unknown rings, discovering 3 new moons, and capturing detailed images of its largest satellites. They confirmed that Ganymede is the largest moon in the solar system, as opposed to Titan, that was previously considered largest. They also discovered that Europa's surface is covered in smooth ice riddled with cracks. It's this data that gave origins to the hypothesis of a subsurface ocean, something we covered in another of our videos. Additionally, the scientists had their first close-up view of Jupiter's Great Red Spot, a centuries-old storm larger than Earth. Jupiter was just the first stage of their grandiose journey. Using its gravity for a speed boost, both probes reached Saturn in 1980 and 1981. This marked a turning point in the Voyager mission. Initially, the mission was planned to last only 4 years to study Jupiter and Saturn, but NASA designed the mission's trajectories to allow for potential exploration of other planets. A key decision was the close approach to Titan, the only moon in the solar system with a dense atmosphere. Ultimately, Voyager 1 was directed toward Titan, sacrificing its ability to continue the journey, while Voyager 2 was sent onwards to Uranus and Neptune. The probes delivered detailed images of Saturn and its rings, revealing that they consist of hundreds of narrow, intricately structured rings. 4 new moons were also discovered. Mimas was of particular interest, notable for being dotted with many craters, including, most notably, the massive Herschel crater, giving the moon a striking resemblance to the Death Star from Star Wars. Titan, however, harbored an unpleasant surprise. Its atmosphere was opaque to visible light, preventing us from uncovering the mysteries of its surface. However, analysis showed that Titan's temperature was close to the triple point, a unique condition where methane behaves similarly to how water does on Earth. After Saturn, the paths of the 2 probes diverged forever. Saturn's gravity significantly accelerated Voyager 1, altering its trajectory and making it the fastest spacecraft in history. Voyager 2, meanwhile, continued its planetary tour, heading for Uranus next. It reached Uranus in January 1986, coming within 50,600 miles of its surface. Scientists were surprised to find that Uranus was vastly different from Jupiter and Saturn. While the gas giants are composed of 90% hydrogen and helium, Uranus contains these elements only in its atmosphere. Beneath lies an ocean of water, ammonia, methane, and hydrogen sulfide, with a core of rock and ice at the planet's center. Later, planets of this type were given the name of an ice giant. Uranus also turned out to be the coldest planet in the solar system, even colder than Neptune. After collecting data on its Uranus mission, Voyager 2 moved onto its final target, Neptune. It reached Neptune in August 1989, and remains the only spacecraft to have visited the 8th and most distant planet in the solar system. On August the 25th, 1989, Voyager 2 captured the first detailed images of Neptune, completing its grand tour. The planet appeared vividly blue, though later data revealed its true color was closer to teal. While Voyager 2 explored Uranus and Neptune, Voyager 1 could only envy the other spacecraft. After its Saturn mission, the engineers disabled a significant portion of its instruments, only leaving technology for studying the environment data. However, after Voyager 1 had another chance to make history. On On February the 14th, 1990, from a distance of 3.72 billion miles, it captured Earth as a tiny, pale blue dot, just 0.12 pixels in size. This iconic photo, known as the pale blue dot, became the last image ever taken by Voyager 1 before the cameras on both probes were permanently shut down.
Mario!
Next, our cosmic travellers entered a long period of calm, lasting a decade and a half, which was interrupted by an extraordinary event. On August the 25th, 2012, Voyager 1's instruments recorded a sharp drop in charged particles emanating from the Sun, along with a rise in galactic cosmic rays. This meant that the spacecraft had finally entered interstellar space, leaving the region where the Sun's influence ends and interstellar radiation dominates. The slower-moving Voyager 2 crossed the same boundary in November 2018. The unique bubble of our solar system, called the heliosphere, extends about 11 billion miles from the Sun. It's formed by the solar wind, a stream of particles from the Sun, and ends at the heliopause, which is the boundary between the heliosphere and the interstellar medium. The Voyagers are the only spacecraft to have crossed this boundary and exited the solar system. What they discovered out there sparked widespread interest and active discourse among scientists. Previously, it was believed that the solar wind gradually weakens as you get further from the Sun. However, data from the probes showed that the solar wind doesn't fade, but instead reaches a sharp boundary. Beyond this boundary, its influence ceases, and interstellar space begins. This means the solar wind doesn't simply dissipate, but changes direction, forming a physical boundary between the two environments. The solar wind flows around the heliopause from the inside, while interstellar plasma flows around it from the outside. We were also able to determine the shape of the heliopause. On one side, it resembles a sphere, while on the other, it stretches into a long tail. Curiously, this shape is not static. The boundary of the solar system is constantly moving. The surface of the heliosphere is distorted by massive waves that appear at unexpected, non-uniform angles. These waves can reach 10 astronomical units, equivalent to 10 times the distance between the Earth and the Sun, or about 930 million miles. Additionally, by studying Voyager data, scientists discovered that the heliopause underwent rapid changes over a very short period. This may explain why the time difference for the two probes crossing the heliosphere's boundary was so large, 6 whole years. However, these changes in the movement of the heliopause contradict existing scientific models and remain unexplained. Similarly, the temperature and density of the solar wind near the heliopause defy explanation. Astrophysicists had expected that the slowing of solar particles by interstellar radiation would cause a sharp increase in temperature and density. While this did happen, the measured values were 10 times lower than the theoretical predictions. Where this energy is lost remains unclear. Data from Voyager 1 and Voyager 2 spacecraft also revealed that interstellar space consists of denser, colder plasma, while the plasma near the solar system's boundary is hotter and less dense. Importantly, these two types of plasma interact with each other. Particles from the solar wind and interstellar wind mix, creating a sort of boundary layer between the heliopause and interstellar space. But the interaction between the Sun and interstellar space doesn't end there. Shock waves emitted by the Sun can pass through the heliopause